Hello students, we had already started our discussion on the chapter aldehydes and ketones. In the last session, we had discussed about the nomenclature, the common system as well as the IUPAC system. So in this session, we'll be discussing the nature of this carbonyl group. Followed by that, we'll be also dealing with the mechanism of the nucleophilic addition reactions. Okay. So as per our discussion in the previous class about the aldehydes and ketones. So aldehydes and ketones are carbonyl compounds. That is, they contain C double bond O groups. Aldehydes and ketones are carbonyl compounds. That is, they contain C double bond O groups. Right? If both the groups attached to this carbonyl carbon are aryl or alkyl groups, then it is a ketone. If one of the group is hydrogen, if one of the atom attached to this is hydrogen, then it is an aldehyde. So this carbonyl group, okay, is polarized. I mean, the bond is not symmetrical. The pi cloud of this carbonyl bond is unsymmetrical. Okay, the reason is because out of carbon and oxygen, oxygen is more electronegative than carbon. As a result, the electron shifts towards the carbon. It gets slightly displaced towards the carbon. As a result, what happens is this oxygen acquires a partial negative charge is what we can say. It acquires a partial negative charge, and this acquires a partial positive charge. So this carbon oxygen bond is polar in nature. Okay. In carbonyl carbon, the carbon is sp2 hybridized. The hybridization of this carbon is sp2. Hence, this is a planar molecule. Okay, and the carbon oxygen bond is polar. Okay, this is because of higher electronegativity of oxygen. Due to the high electronegativity of oxygen, so the electronic cloud gets slightly displaced towards oxygen atom. As a result, the oxygen will acquire a partial negative character charge, whereas the carbon will acquire a partial positive charge. So hence, due to this polarity, whenever a nucleophile attacks, so the nucleophile always attack the carbonyl carbon only. Why the carbonyl carbon only? Because the carbonyl carbon carries a partial positive charge. Okay, so this positively charged carbon is readily attacked by electron-rich nucleophiles. Okay, so today in this session we'll be discussing about this nucleophilic addition reactions. Okay, I will just tell you the mechanism of this, how actually a nucleophilic addition reaction takes place. Then we come across two types of addition in there. There may be an acidic catalyzed addition, or it may be a base catalyzed addition. I will tell you what actually happens in an acid catalyzed addition and what happens in a base catalyzed addition, and then we'll take a specific examples and we'll solve it. Okay, now, so a carbonyl carbon. Okay, just I'm dealing with the mechanism of nucleophilic addition. Nucleophilic addition. Now, so the nucleophiles are generally electron-rich centers. Generally, we represent them as Nu minus, right? So the nucleophile attacks the positively charged carbonyl carbon to form a new bond. So this attacks this carbon only. Why it attacks the carbon? Because the carbon acquires a slight positive charge, and the oxygen acquires a slight negative charge. So nucleophiles are electron rich, hence it attacks the carbonyl carbon only. As a result, what happens is here, as it says, this is a step one now. This is step one. I'm just telling you the general mechanism what happens, right? So nucleophile attacks. So when a nucleophile attacks, a new bond between nucleophile and carbon is formed. So a new bond is formed. So hence older bond should break. So as a result, the electron moves towards oxygen atom. Okay, if this electron doesn't move, then what happens is the carbon will acquire 5 bonds. So it's not possible. Carbon can have a maximum valency of 4. So hence what happens, if a new bond is formed, the old bond should break. So this is what happens. So this is the 2 bonds. The nucleophile attacks. Double bond O, it becomes single bond O minus. So you get an intermediate here. Okay, this is the intermediate that is formed. This is called as a tetrahedral intermediate, or a transition state is what you can say. So this is the step 1 that occurs. Step 2. Okay, this intermediate will take up a proton. Okay, it will take up H plus ion, an electrophile. You can take an electrophile. So since it is a negatively charged, obviously an electrophile should form a bond with this, right? So the electrophile attacks this negatively charged oxygen atom to form an addition product. So usually when you are using a solvent, usually H plus will be present there. So it takes up, for example, H plus. It may take up H plus to form this compound. Simple. This is the product. This is the addition product that you get. So the reaction is simple. So nucleophile attacks, double bond O gets converted into single bond O minus. This O minus takes up a proton to form OH. Okay, or any other electrophile that is present in the medium it takes up, right? So the addition reaction is simple. So nucleophile attacks, double bond gets converted into single bond O minus will take plus H plus to form OH. Okay, now there are 2 types of addition. One is acid catalyzed addition, other one is base catalyzed addition. So let us go for acid catalyzed addition. Okay, you can carry out this addition reaction in presence of an acid or in presence of a base also. So let us see what happens in case of an acid catalyzed addition and what happens in the case of a base catalyzed addition. Okay, so what happens is here. Now, step 1. We have a carbonyl compound where the carbon is positively charged, oxygen is slight negatively charged because it also contains lone pair of electron. So you are carrying out this addition reaction in presence of an acid. So what happens is acid produces H plus, you know this. So what happens is first this oxygen forms bond with this H plus because it contains lone pair and it is slight negatively charged also. So it attacks the H plus that is produced from the acid. As a result, this is formed OH. So this will acquire a positive charge again. Are you getting my point? This will acquire a positive charge. Why? Because it has donated its electron, lone pair of electron to H plus, so it will acquire a positive charge. To utilize this electron moves here. This electron moves here, resulting in the formation of this compound. See, OH, positive charge, because the electron moves here, this carbon carries a positive charge. Are you getting this? So the hydrogen ion from an acid attacks the negatively charged oxygen to give a protonated carbonyl group. this protonated carbonyl group in resonance is resonance stabilized. Okay, so this protonation makes the carbon more electrophilic. It makes this carbon more electrophilic. So now what happens in second step? Second step. And the second step, this nucleophile attacks this carbon. Now, resulting in the formation of the same product only. This is what happens. So you are obtaining the same product only. The only reason is the use of H plus catalyzes the reaction. That means it forms a bond with this oxygen. So you get a protonated carbonyl compound which is in resonance. So as a result, what happens? The carbon acquires a positive charge here. So it becomes more electrophilic. So attack of nucleophile will be easy. Okay. So weak nucleophiles such as water, alcohols often add to this carbonyl group under acidic condition. So weak nucleophiles cannot attack unactivated carbonyl group. Okay, but protonated carbonyl group is more electrophilic, hence it allows attack by the weak electrophile also, the weak nucleophile also. For example, if you don't use H plus and if you carry out the reaction in presence of, if you use water as a nucleophile, the attack may not take place. So hence, in presence of this acid, so weak nucleophiles like water also can attack easily. Okay, if the nucleophiles are generally weak, so then they are carried out, then the reaction is catalyzed by H plus ion. So the reaction is carried out in presence of an acid. So this is the mechanism of the acid catalyzed reaction. Okay, let us go for the base catalyzed reaction. So once base catalyzed reaction we go for, then you can find the difference between these two things, right? Base catalyzed addition. What is this base catalyzed addition? Right now. So what is a base? A base is a substance that generally abstracts a proton, is generally referred as a base. So when you carry out the reaction in presence of a base, you are going to get the same product only. But the mechanism will be different. Let us see what happens in step 1. Step 1. What happens? So I have a compound. I'm carrying out this reaction in presence of a base. Okay, we are carrying out the reaction in presence of a base. So you know what are bases. Okay, bases are generally the compounds that have tendency to abstract a proton. So base abstracts a proton here. Okay, it takes up this proton. So it takes plus H plus. So this electron moves here. So it results in the formation of BH plus nucleophile is generated. Okay. So what happens is a base converts this weak nucleophile into a strong nucleophile by removing a proton. So this converts to a strong nucleophile. So what happens in the step 2? In step 2, carbonyl group. Nucleophile that is formed attacks this carbonyl group, and the same attacks. Double bond O becomes single bond O minus. This O minus takes up a proton. Okay, it takes up a proton from this BH to form OH. The electron moves here and the base will be generated. Simple. See, look at the base catalyzed reaction and the acid catalyzed reaction. In acid catalyzed reaction, the acid protonates this and makes this more electrophilic. Whereas in base catalyzed reaction, what it does, base removes a proton and makes a weaker nucleophile into a stronger nucleophile. So this is the basic difference between the acid catalyzed reaction as well as a base catalyzed reaction. Okay, now. So this is how actually the reaction takes place. Now let us take a specific example and let us try to solve it. The first example that is for your syllabus is addition of hydrogen cyanide. Yeah, okay. Now, addition of hydrogen cyanide. Now, please do concentrate. Aldehydes and ketones, they react with hydrogen cyanide to form corresponding cyanohydrales. Here, Cn- acts as a nucleophile. The reaction is carried out in presence of a base. The reaction is carried out in presence of a base. Okay, let's take a simple reaction for this. If you have a carbonyl compound, if you treat this with HCl, what happens is HCN dissociates to give you H plus Cn minus. Okay, if we carry out this reaction in presence of a base like OH minus, this OH minus helps this in removing a proton and it generates Cn minus. Whatever the Cn minus formed attacks the carbonyl carbon to form this. Cyanide attacks the carbonyl carbon, double bond O gets converted into single bond O minus. This O minus takes up the proton to form OH. So these compounds are called cyanohydrales. These compounds are called cyanohydrales. For example, I will take this compound CH3C double bond OH. This is acetaldehyde. This is acetaldehyde. Acetaldehyde, when it is treated with hydrogen cyanide, what happens? So we have CH3, C, we have H. Cyanide attacks this. Double bond O gets converted into single bond O minus. O minus takes up a proton to form OH. So this molecule is called as acetaldehyde cyanohydrate. Acetaldehyde cyanohydrate. Okay, let us go for the mechanism of this. Okay, this is a base catalyzed reaction, and you know what happens in a base catalyzed reaction. In a base catalyzed reaction, a base removes a proton, it generates a nucleophile, and then nucleophile generates. The same mechanism is what we are going to repeat by taking hydrogen cyanide. Okay. Mechanism. Mechanism. No. Step 1. Okay. In step 1, OH minus of the base, it removes a proton and generates Cn minus and water. Right? Now, cyanide ion is formed in first step. In second step, whatever the cyanide ion that is formed attacks the carbonyl carbon to form the anion. It attacks the carbonyl carbon to form anion. For example, if you have this carbonyl carbon, the cyanide ion that is formed attacks the carbonyl carbon. You know why it attacks the carbonyl carbon? When it attacks the carbonyl carbon, a new bond between carbon and cyanide is formed. Double bond O gets converted into single bond O minus and anion is formed. This abstracts a proton from the solvent. Okay, usually the water that is formed. Okay, it abstracts the proton. Okay, to form corresponding cyanohydride. This is what is happening. Simple reaction. As you all know that if you carry out the reaction in presence of a base abstracts a proton to form this. This attacks the carbonyl carbon, then an abstraction of proton to form this. So this is what happens. Okay, now next one is addition of hydroxylamine. Addition of hydroxylamine. Aldehydes and ketones reacts with hydroxylamine. What is the hydroxylamine? Hydroxylamine is NH2OH. This is called as hydroxylamine. To form corresponding oximes. Okay, they react with hydroxylamine to form corresponding oximes. Let us see what happens actually. If you have a carbonyl compound, if you treat it with hydroxylamine, this nitrogen attacks the carbonyl carbon. Nitrogen attacks the carbonyl carbon. Double bond O gets converted into single bond OH. Then after the addition, loss of a molecule of water takes place, resulting in the formation of a condensation product. So actually the addition of hydroxylamine results in the condensation with the loss of water. So this is what is formed. C double bond N OH. We call these compounds as oximes. Okay, to give a specific example, I will take this example. CH3 C double bond O CH3. This is acetone. When it is treated with hydroxylamine, not only hydroxylamine, any of the amine derivatives, it is condensation taking place. Resulting in the formation of this product. Okay, if you use hydroxylamine, the product obtained is called oxime. So since it is produced from acetone, this is called as acetone oxide. Let us discuss the mechanism of this. Let us see how this is formed actually. Right now. So step 1. Carbonyl compound. Okay. So what happens is you have an hydroxylamine, that is you have NH2OH. N. So you are treating this with. So this nitrogen contains lone pair. Hence it attacks this carbonyl carbon. Okay, it attacks this carbonyl carbon. So resulting in the formation of this. Okay, a new bond is formed between carbon and nitrogen. This double bond O gets converted into single bond O minus. This nitrogen OH. This carbon acquires a positive charge. because it has formed a new bond. Okay, so hence loss of proton takes place. It's positive charge, so it pulls this electron here. It takes up the electron. Whatever the H plus that is lost, it combines with this to form OH. See, you have OH, then now you have NHOH. This is what happens in the first step. Okay, you get an adduct is what is formed, right? You generally get this adduct, right? Now in second step, in the step 2, in step 2, this undergoes dehydration, that is loss of water molecule takes place. H from here, OH from here goes off, so loss of water molecule takes place, resulting in the formation of C double bond N OH. Oximes are formed. This is what happens, right? So this is about the addition of hydroxylamine to carbonyl compounds, as well as the addition of hydrogen cyanide to the carbonyl compounds. Okay, so students, so this was about today's session. In this session we have discussed about the nucleophilic addition reactions, right? Nucleophilic addition reactions, what happens for an acid catalyzed, what happens for a base catalyzed, general mechanism, and hydrogen cyanide in presence of an acid catalyzed reaction, sorry, base catalyzed reactions. Okay, and then addition of hydroxylamine to form oximes. So in next session we'll be dealing with addition of alcohols in presence of acids. Okay, then formation of cyclic acetals, and then we have some named reactions like aldol condensation, Cannizzaro reaction mechanism. Okay, this is what we are going to deal in the next session. Okay, thank you.